I get started, a couple of announcements, or at least one announcement. Being at NIST and being a government employee, I can't endorse anything, but I'd like to mention John Buckleton's book. He and Christopher Triggs and good friend Simon Walsh, contributors here to this effort on forensic DNA evidence interpretation. This is an excellent book. It's very easy to read. There's some excellent work in here on MITO and why. I refer to this book quite often. And so Debbie wanted to mention this if you're interested in reading more about the likelihood ratio and so forth. During the break, also, someone mentioned that in addition to the work that we've presented on likelihood ratios and random match probability, so what Chris and John were showing was a restricted likelihood ratio where they're conditioning on a suspect or at least the person who was wearing the underwear. You could also do, in some labs, do an unrestricted likelihood ratio. So in that example where the 29-29 combination was determined as very unlikely based upon the peak height ratios, a laboratory may be more comfortable, or according to their policy or what they have in their SOP, to include that as part of an unrestricted likelihood ratio. So you would include that potential combination in the statistics. So something else to keep in mind as we work through these. There are multiple ways and approaches for doing even a likelihood ratio.
And Mike, I would probably point out for those of you, and I think most of you use pop stats, there's no way to do a restricted likelihood ratio using pop stats. So you would all be doing unrestricted.
So I'm going to do a dangerous thing, and I'm going to start talking without either Todd or Chris in the room. So we'll see how this goes. So I again apologize for the confusion in the nomenclature here. This is mixture 1. It's a 50-50 mixture, and this is called example 2. So if we take a look at the overall picture of the mixture here, I would say that this is a 2-person mixture. We see no more than 4 alleles at any one locus. So here the 4 loci that have 4 peaks. Notice there's no easily defined major or minor here. So pretty much as the example says, it is a 50-50 mixture. Are there any stochastic issues? Well, no. Everything looks to be pretty well above the stochastic threshold. No real issues there. So this is pretty much a straightforward 2-person mixture. No distinct major contributor. It's about a 1-to-1 ratio. And there are no loci with alleles below the stochastic level. So again, you could fill out on your sheet all of the alleles that you see. None would be in parentheses or in red. Pretty straightforward. So this is the sort of type A mixture according to the German scheme. And so this is an indistinguishable mixture. You would need to perform a statistical analysis here. So we're assuming that this is evidence from a burglary. There's a leather glove left behind the scene. The glove fits the person of interest. So if we're going to do CPI, again, based upon what the labs I've talked to said, that they would simply just take the summation of the allele frequencies for 8, 9, 10, and 11, and then pretty straightforward. TPOX, pretty much the same thing. There's no real evidence that there's some minor allele somewhere, like a 7 or an 11. So you just take the frequency of 8 and 10. And then for D18, this is another loci that we said we would look at. We would sum 12, 14, and 20. So here we would exclude almost 92% of the population. But I wanted to point this out. Chris McGuire pointed this out in his lecture on Tuesday, that using the CPI, the CPE, you tend to discard a lot of information. In this case, if I were a 12-12 homozygote, I would be included in this mixture, and I would be pretty pissed off. So in doing so, you assume that there's a 12-12 homozygote in there. That's what you're doing with your squaring of the frequencies. And that would leave the other combination of 14-20, which is, again, you're looking at a different mix ratio, and you're also looking at a peak height imbalance of about 50% or so, less than. So I'm going to move on then to let Todd look at these same three markers from a random match probability view, so we're not doing a different mixture.
Let's see if I screwed this one up.
Is this right?
Prompt 2, so we start off. Yeah. Yep. So again, this is the little snippet from our spreadsheet. At D7 in this case, there were 4 alleles. This is pretty easy locus, good one to start with, but at a 1-to-1-ish mixture ratio, these are all equal, all combinations that are possible. Oops, that doesn't work yet. Where's the real pen? You go through, these are all the combinations of those 4 alleles. Do the 2PQ across the board for each of those. So the individual genotype is just your random match probability, the 2PQ, et cetera. You get your random match over here, and then just sum it down. I don't know if you can see that. It's about 0.45%, well, 45% of the population would be included as a potential contributor to that locus. We all good? And again, just to point out, in this case, this is really all the heterozygous genotypes. You're excluding any homozygotes because this is the assumption that it's a 2-person mixture. You can't have a homozygote in this and still have, that would leave 3 alleles, so the guy would have to be a triallele. So this is one of those situations that, yes, we would interpret this based on a 2-person mixture. It's really the CPI minus all the homozygote genotypes. If for whatever reason we run a reference sample and we've limited basically just to these genotypes, and it turns out this guy's a triallele there, that might give you an excuse to go back and potentially reinterpret this or call it inconclusive. But 99.9% of the time, this is what your interpretation is going to be, and you have to have a good reason to go back and potentially reinterpret that locus. So TPOCs. We've got 2 alleles. Going through this whole thing with the 1-to-1 ratio, the only one that really makes sense and fits the model is the 8-8 with an 8-10. Everything else is excluded. So again, I did not pull out a minor component here. This is good. So you have the 8-8 and the 8-10 as possible genotypes. Calculate the single RMP for each of those, sum them, and you're including about 35% of the population at this locus. At D18, go through the 12-12 with the 14-20. It's not possible. We're ruling these out based on your minimum expected peak height ratios. And this is exactly what Mike was just saying is, if you're a 12-12 based on a 2-person mixture, that's going to leave the 14-20. And that goes against what our minimum expected peak height ratio would be. So that would be excluded. And again, if I'm the defendant sitting at the table and I'm a 12-12, I'm going to be a little bit bitter that you're including me as a potential contributor to this. So you go through all those. It really comes down to there's only 2 combinations that fit within the model. Those 2 combinations result in these 4 genotypes. Calculate the individual genotype frequencies, sum them down. Now you're down to about almost 5% of the population would be a potential contributor. I think, what was CPE at this?
91%.
Yeah, so I mean, they're pretty close, but it's, you know, the RMP is giving you a little bit more discrimination. So when you get to, oh, sorry, never mind. It's like there's no dropout here.
Okay, so Chris will go through, this is the likelihood ratio example, the likelihood ratio explanation of the data. Okay.
Okay. Let's have a go at this, see if I can manage this one without making a screw up again. Okay, so in this instance we have person of interest equals 2020. Okay. Prosecution hypothesis. Person of interest plus unknown. Everyone happy with that one? HD. Shout it out. Two unknowns, thank you. Okay, so let's take the top line. If we've got a person of interest of 2020, what am I left with on the top line? I've got to account for a 12 and 14, excuse me, and if we take John's model, I've got 2 fact over 1 fact, so I've got 2 F12, F14. Okay, if I then take 2 unknowns, I've got to account for everything I see, which is a 12, 14, and would you agree 2 doses of 20? I've got no dropout there. Which is, that's going to be 4 factorial for the 4 counts plus 1 factorial, and 2 factorial for the 20s. Yeah, okay with that one? Write it out, okay. So I've got 4 factorial, because I have 4, an order of 4 alleles there. I've got 1 factorial for my 12, my 112, 1 factorial for my 114, and 2 factorial for my 2 20s. Everybody okay with that? Yeah. 4 factorial is 24 over 2, that gives me 12, so I've give myself space. So I should have, that goes down to 2 F12 F14 divided by 12 F12 F14 F20 squared. We okay with that? Which goes to 1 over 6 F20 squared. Okay with that? And whatever 20 is, I'm not sure you do the math. Okay, thanks much. Do you want to do the next one? Which one? Oh, okay. This should be interesting. Just give me 2 seconds. This one's quite interesting. Person of interest is an 8-8. So I've got to account for the 8-10. Is it reasonable in this instance? I'm going to have an 8-8 pairing with an 8-10? Yes, it is. Okay. Is it reasonable that I've got an 8-8 pairing with a 10-10 in this particular mixture? Given that we've got 1-to-1. And I said, okay, I'm seeing nodding heads, shaking heads. Are we yeses or nos? Thank you. Okay. So that's really a fundamental decision. I've got an 8-8 with an 8-10. So my top line becomes 8, 10. That's 2 factorial over 1 over 1, that's 2. And then on the bottom I've got to count for all of it. Would you accept, in this instance, I'm going to have that. In this case, I've got 4 factorial divided by 3 factorial because I've got 3 orders of 8 and 1 factorial for the 10. Silence. John, I appreciate now what you went through on Tuesday. Okay, and yeah, question there.
I was beginning to, could you just go back and do this one the conventional way?
The conventional way, okay.
Right, without the factorials? Just to set it up?
Okay, let's give that a go. Can I just finish this first, and then we'll go back and do that? Okay, because otherwise I'll get myself lost. Now, 3 factorial is 6 divided, so that's 1 over 4. So I've got 2 F8, F10 over, where do we go from here? 24 over 3 times 2, 6 is 4. F8 cubed, F10. Yep. Everybody happy with that? So I'm going to get rid of some of this. 1 over 2 F8 squared. Because that goes and that goes and that goes and one of those go. Yeah, okay. I like that. I mean, this is new to me and it's fascinating. It's so quick. Right then, conventional way. We've agreed that we've got fanfare. We've agreed we've had the conversation. What have we got on the top line? We've got the 8-8 and an 8-10. We've got to account for that. What's on the bottom line? What's allowable? What are the allowable pairs? What pairs have we got? We've got an 8-8 and a 10-10. 8-8, 8-10. This is going to be 7, isn't it, Chris? Come on. You can do this. I've got to have an 8, 8, 10, 8, 10. That's the 2 hets. I've got to do reverses of those. 10, 10, 8, 8, 8, 10, 10, 8, 8, and there's 2 4s, 2 missing. What am I missing? 10, 8, 8, 10. Oh, the 10, 10s. 10, 10, 8, 10, and there should be one more for a 2-person one. Yeah, 8, 10, 10, 10. Yeah, okay. Given that, what do you think is allowable? And given we have, from all other respects, is it 1-to-1?
Yeah.
150, 0.5 as a mixture ratio. Is an 8, 8, 10, 10 allowable? An 8, 8, 8, 10? Yes? An 8, 10, 8, 10? 10, 10, 8, 8? No, that goes out. 8, 10, 8, 8? Yes. 10, 10, 8, 10? No. And 3 10s there? No. So we only have 2 allowable combinations on the bottom, I guess. 8, 8, 8, 10, and the reverse. 8, 10, 8, 8. So I've got a 2 there, haven't I? 2 F8, F10. And what have I got on the bottom? Combinations allowable is an 8, 8, 8, 10. 8, 10, 8, 8. God, you don't know how hard it is doing this up on 8, 8, 8, 10. So there's only 2 combinations. I'm stuck again, sorry guys.
So, Chris, you've got 2 combinations.
Yep.
So there's a plus sign.
Of course, yeah, okay.
So stick the plus sign in. And the first one is f of 8 squared times 2 f of 8 f of 10.
Yeah, okay, John.
The second one is 2 f of 8 f of
2. Times F8 squared.
Yes.
Which gives me, can I do any cancelling there? That times. Which is going to give me 2 F8 cubed F10. Yeah,
Need another factor of 2 bottom line.
in the bottom line there.
Well, no,
No.
basically there's 2 terms that are the same.
Yeah, it's there.
No, it's all good. It's just when you add the 2 together, you get the 2.
Oh, there, of course. So I've got 4 there, haven't I? Which takes us back to where we were before. Sorry, guys, it's stressful up here. Okay, we end up with 2 F8 F10 divided by 4 F8 cubed F10. Doing it that way round. That's all the workings out. Do you get marks for the workings out? I don't know. Oh, thanks. Which, when we cancel through, gives me 1 over 2 F8 squared. Sorry for that being fairly tortuous, but we get to the same answer in the end. Okay. Sorry, Mike. There we go.
And once again, this example we've seen this before. Todd had an example of this in his talk where if you're doing a restricted likelihood ratio, then you would condition upon the person of interest, the 10, 11. So it would be 1 over 2 P 8 or 2 F of 8, F of 9. And then if you're doing an unrestricted, you would have to take every possible combination of two, so 8, 9, 10, 11, 8, 10, 9, 11, and so forth. And that's where Todd derived that. Where does that, 2 over 24 A, B, C, D, where does that come from? And Dr. Bulkington mentioned that one too. So that would be if you're doing an unrestricted likelihood ratio. The final homework problem was a problem that was not in your packet of mixture examples. This is a problem that Todd brought to the table. And the first two examples were very nice. We could work our way through them. Everything was well above stochastic threshold. We had no issues with minor alleles that would create discomfort. Here's an example of what you may actually see in a real case. It's about a 50-50 mixture ratio. So, unlike example 2, we're now looking at markers where there are stochastic effects. So I have a very easy job since I'm doing the CPE here. We would give a value of 1 and 1 and 1. So basically you would not be able to use the 3 markers here because there's in this example all of the there's at least one allele below the stochastic threshold. So I'm going to turn this over to Todd and let him talk about his approach. Yes.
You talked about what you would do at those 3 loci. Can I get your opinion on what you do with the entire mixture?
This is an example where I would not feel very confident in moving forward since there's so many markers with loci below stochastic threshold, and even loci where, like FGA, there's an allele that's below your analytical threshold. So I think you would have to just evaluate the entire mixture and say, I'm not so sure if everything's fully there in this example. I mean, it looks like a 2-person mixture, but there's potentially some evidence there may be more than 2 people, but it's very, very difficult to reliably say I'm going to move forward with this mixture. If you say assume, then you're going to move into the RMP world, random match probability or likelihood ratio. But with random and not excluded, where you're making no assumptions, then I would say no.
And I think that's the key difference is, with CPI, you have to be, random man not excluded, you have to be confident that you have complete representation of all minor components or all components of the mixture. With likelihood ratio or with RMP, you can make that assumption of 2 individuals, and then as long as you have at least partial representation of all components, you can move forward with it. And in this case, I was going with the assumption that it's a 2-person mixture. I feel pretty confident with that, mostly because I actually made this, so I know it's a 2-person mixture. Unless there's some contamination in there, which I'm not too worried about that because I'm actually one of the components in here. So this is my world. This is why I want to do this because I think as more labs are moving away from, not moving away from sexual assaults, but as they're moving towards touch evidence. I was talking to Sean. Their lab, the proportion of sexual assaults has dramatically gone down in their lab. They're still doing the same number of sexual assault cases in a lab, It's just the amount of touch evidence they're doing is skyrocketing. And so as labs are moving more and more towards doing touch evidence from guns or whatever it may be, you're going to see more of this type of stuff. And this is what we saw. When I first was at the ATF, we were doing CPI, and we were throwing away all this data. We'd get something like this, and I wanted to stick a spoon in my eye because there's good data there, but we can't use this for anything. And so I spent a year and a half, 2 years looking at different things, and I did not develop RMP. That was out there. I talked to Stephen Myers. I talked to Dr. Butler, Dr. Buckleton, many others, trying to figure out how we can use this data without going too far and having people coming and testifying against me that have PhDs after the names and me losing my job. So this is what we kind of settled on, this RMP approach, and this is addressed in the SWGDAM interpretation guidelines, which is nice.